Good day, everyone. Today, we will discuss the topic about specialized production system. Eh, In this topic, we will be dealing the production system for ornamentals and plantation crops. First for ornamental plants. Ornamental plants, which is under ornamental horticulture, are plants that are grown for decorative purposes in gardens and landscape design projects as houseplants, cut flowers, and specimen display. So at the side is some very colorful, prolific flowering plants. And under ornamental horticulture, by the way, ornamental horticulture is one of the branches of horticulture aside from olericulture, pomology, and plantation or industrial crop productions. So under ornamental horticulture, there are two categories, and the first is floriculture, which is defined as the study of growing, marketing, and arranging flowers and foliage plants. And there are three people, or yes, people engaged in floriculture, and these are the floriculturists, florists, and arborists. Floriculturists are those who engages in growing flowers. So they plant flowering plants, they take good care of these flowering plants, and then florist on the other hand specializes in selling flowers, flowering pot plants, foliage plants, and forest greens. So take note of the difference. Floriculturists will do the culture, will do the planting, while the florist will do the selling of the flowers or flowering plants. Okay, the arborists, on the other hand, are people concerned with the planting and care of ornamental trees and shrubs, both in private and public grounds. And there is, or horticultural plants are classified into different groups or categories, and the first one is cut flowers, otherwise known as florist crops. And these are flowering plants grown in greenhouses and outdoors whose flowers are cut for market when they are in full bloom. Oh, just like this very beautiful, colorful anthurium. And the second is flowering pot plants. Okay, these are plants sold as whole plants when in bloom and are grown in containers. And they are usually used for display purposes, just like this plant here at the side. So it's inside a container. And another one is the foliage plants. So these are non-flowering, or they can be flowering plants grown for their attractive foliage, just like this plant here. Okay, this aglonema, which has attractive leaves or foliage. So we grow this plant for because they have this attractive foliage. The forest greens, on the other hand, are grown for their foliage also, but is used to provide background in floral arrangement for corsages making, bouquet, and wreath. And a very good example here is the ferns and also lycopodium, pea plant, asparagus, and many others. So the foliage and the forest greens are grown for their foliage, but the difference is that for foliage plants, it's the whole plant that is being displayed or grown for their attractive foliage. But for the forest greens, they are used to as background for floral arrangement. So they are not the main uh, the main crop. It's the flowers uh, used for corsages, bouquet, and wreath making. And then, lastly, the landscape plants, which covers almost all the ornamental plants used for landscaping purposes in a specific area. So just like the picture in the side. So we have many or various plants, assorted plants being used to beautify an area. Okay, the second category under ornamental horticulture is landscape gardening, which is the implementation of a landscape design. And what is a landscape design? So this is a planning or making planting plants for outdoor space, for basement's needs, for function and beauty. And the pictures below uh, is an example of a landscape area or grounds being being landscape, not following a landscape plan or a landscape design. So you can see the area being or rendered beautiful to see because of the appropriate arrangement of the different plants used. So why beautify our surrounding? So this is of course, we beautify our surrounding to make us happy because an area being planted with different crops look beautiful and it is always our aim. And it's please take note that it's not only the ornamental plants that can beautify our surrounding. Other plants too can be used in landscaping together with the ornamental plants, and we call these edible landscaping. So this is with the use of plants that can be eaten, planted together with ornamental plants. What is edible landscaping then, or EL? Okay, this is a new approach that merges science and creativity together to form a revolutionary crop production technology. It gives a twist in the conventional crop production as the basic tenets of landscape design or designing becomes its guiding principle. So there's really a difference with the conventional crop production because the implementation of this edible landscaping is guided by principles. And what is edible landscaping? So it gives primacy to the use of vegetables and herbs as major softscape materials as substitute for the ornamental plants that are normally used in conventional landscaping. It's not only ornamental plants. It's together. It's not really substitute, but these vegetables and herbs are planted together as together with the ornamental plants. In the conventional landscaping, as we know, okay, this only makes use of the ornamental plants. Okay, we compare edible landscaping versus vegetable gardening. Okay, while in vegetable gardening, vegetable plots are allocated at, or situated at the back spaces of home gardens in backyard gardening, EL occupies the premium spaces in front of the house or the so-called public area of residence. So take note of the difference. Usually the vegetable gardening production is, or the vegetable garden are situated at the back of our home, whereas this edible landscaping, it occupies the front spaces of our home or in public area of residence. So this is an example of an edible landscaping where we can see that together with the vegetables are also these ornamental plants. So the vegetables are the one we refer to as edible because we eat them. So clearly you have this corn, you have this pechay, uh, and you have this flowering plant here. Also below, we have this philodendron. Uh, we have this again. We have this pechay, and we have this lantana. So a combination of these vegetables and ornamental plants for edible landscaping. And why do we need to do it in EL way or in landscaping way? So we should know some facts and figures. Okay, on on this aspect. So we should know that Pinoys or we Filipinos eat less vegetables. And according to the World Health Organization recommended daily allowance, we should eat 400 grams of vegetables a day. And look at the consumption, vegetable consumption of Filipinos. So we have here the age bracket and first column, and the consumption of vegetable in the second column. So for 6 to 11-month old baby, 2 grams, 2 grams per day. 1 year old, 8 grams. 13 to 19 years old, 69 grams. So I guess no, most of you fall in this age bracket, no, 13 to 19 years old. So you are eating about 69 grams of vegetables a day. Now for 20 to 59 years old, so I am this category. So we are eating 91 grams of vegetable a day. Over 60 years old is 81 grams. Pregnant women, 91 grams. Lactating is 101 grams. Now for the RDA recommendation, our recommended daily allowance is 400 grams. So we are far behind. No, our consumption is far behind the RDA of the World Health Organization. So we should strive to eat more so that at least we will be near to this RDA value of 400 grams vegetable consumption a day. So there are some reasons why Pinoys or why we don't eat vegetables or less eating of vegetables. So these are reasons or perceptions that first, fruits and vegetables are expensive, which is true. In some vegetables only, just like the members of the Brassicaceae family, they are expensive. The cauliflower, the broccoli, they usually cost around 100 to 150 pesos per kilogram. And then second vegetable is seasonal. This is also a fact because we have plenty of vegetables during summer, but lesser or fewer vegetable in the bare months of September, October, November, December because of unfavorable weather condition. There's always few rains during during the bare months, which limits production of vegetables. And it's also true that it will take a longer period of time to prepare the vegetables, unlike if we just eat in the fast foods, no, in the McDo or in the Jollibee in Mang Inasal, where we just sit down there and then order in a few minutes so we can have our orders. Also, fruits and vegetables spoil quickly, and lastly, fruits and vegetables contain harmful pesticides. So this last, fruits and vegetables contain harmful pesticides. This is true if the grower is not practicing the GAP protocol or the so-called good agricultural practices protocol. Because uh, under this protocol, the growers or farmers have to follow the recommendation on the dosage and on the frequency of application of chemicals. So it doesn't mean that the growers cannot apply chemical pesticides. They can, but at a regulated rate. So the goal of the Filipino people is entice people to plant what they eat and eat what they plant. So I hope you will get this. Entice people to plant what they eat and eat what they plant. And we are going to do this through aesthetically producing their own food or our own food. So this is production of vegetables or plants, considering or in relation to beauty, beautifying our surroundings, so that at least we will be encouraged or enticed to plant more and produce more so that we'll have something to eat. Also look at the pictures below. The vegetables are planted in a nice way, in a nice arrangement, together with ornamental plants. So we should follow landscaping principles in doing this edible landscaping technology. So you can also see here that plants are arranged in a pattern. They are in rows, not just scattered. So doing this will make the plants or the arrangement as a whole becomes beautiful to look at. And why do we need landscaping? It's because well-designed and properly installed landscape can increase property value by 17%. So it means mamahal ang value of a property, of a land, uh, of, uh, of a house if it is well landscaped. Okay. Another is that poorly conceived and executed landscape can decrease property value. No? Dili ganahan ang mupalitay ani, no? Kung dili gwapa. Waste of time and money and be present liability risk. So look at the picture at the side. So before landscaping, not so beautiful area, but after the area is being landscaped, so we can see now a beautiful place, a beautiful building or a house, and with this there should be or there is an increased value of the property. Another reason for landscaping is it will give enjoyment to the homeowner. And of course, not only the homeowner, but those passers-by, no, they can always see that this is a beautiful landscape area, and they also enjoy. I hope you do the same, no? Because in my case, no, makalabay lang ko, no, house that is beautifully landscaped, malipay ko appeal. No? Plants in the landscape will convey the enjoyment we have is due to the warmth, the protection, the comfort that is being offered by the plants that are properly landscaped. So what can you see? Or what can you say with this area or with this building? So you can see that this is a concreted building or house with a roofing, with a walling. Uh, it costs, I'm sure, this is expensive. However, this is boring to look at. Mingaw. Uh, why lamig tanahon? It's because there are no plants. This is not landscape. So this is not if this is being sold, so it can command a higher price. Okay. For ornamental plants, there is always that aspect of the control of flowering because we are most of the particularly for the flowering plants or for the forest crops, so we are after of their flowers and control of flowering of many crops can be done via different or via considering different phenomenon, and one such is photoperiodism, which is the developmental response plans to the relative length of light and dark periods. Length of light and dark periods. And with this aspect on photoperiodism, there's always the we should always learn or understand the critical day length of each of plants. Uh, Plants differ in terms of critical day length, which is defined as the day length which separates inductive from the non-inductive ranges of photoperiod. So somewhat this is a boundary line of plants or the period of light which can induce the plants to flower or which can inhibit the plants to flower. And there are three classification of photoperiodic plants. And these are the lonely plants, short-day plants, and day-neutral plants. Short-day plants requires a relatively short daylight period because they are short day, so they require short daylight period, usually 8 to 10 hours, and a continuous dark period of about 14 to 16 hours for subsequent flowering. And since they are short day plants, they are also known as long night plants. And examples here we have chrysanthemum, poinsettia, coffee, soybean, tobacco. So picture shown here is what's this? The poinsettias or the Christmas flower. So we can see this plant flowering during the beer mass, especially approaching December and the early part of the year. In terms of its reaction on flowering or non-flowering, so this broken line represents the critical date length. So that the boundary line or critical date length or length of uh, light, which determines the below or above which plants will flower. So on above part is the dark period and below is the light period of exposure. So we have here for this plant in A, when it is exposed to light that exceeded the critical day length and there is shorter dark period, the plant will not flower because this is a short-day plant and it is being exposed to lonely condition in this case. And when the short-day plant is exposed to short day length, it is below the critical day length, this broken line, so it flowers. So you can see there a flower. And letter C, okay. Again, uh, this is similar with this letter B. There is exposure of short day length. However, the night period is being interrupted with a red light, and this interruption causes the short day plants not to flower. So no flowering with the interruption of this red light during the dark period. And letter D, same with B and C. The plant here is exposed to short day condition. And yes, it's below the critical day length. However, it is being interrupted. Uh, During the dark period, there is an interruption of the red light, which is followed by far red light or FR, and this is inductive to the flowering of these short day plants. Okay, letter E. This letter E is also exposed to short day condition and interruption of red, far red, and red light. So the last exposure is red light, and so this plant don't flower. So the exposure to red light uh, causes the short day plants not to flower. And for the last plant in letter F, we can see here flower. The plant is still exposed to short day length, but then there are several interruptions, and just like here in letter D, that FR being the last exposure causes the short day plants to flower. So with this, we can say that it's the last exposure of the light being used to interrupt the dark period that will determine whether the plants will flower or not. So here, if it is with light, the plants will not flower, but if R, the plants will flower. The other category of photoperiodic plants is the lonely plants or the LDPs, and they require longer daylight period, usually 14 to 16 hours for them to flower in a 24-hour cycle. And then we can expect subsequent flowering with this exposure to light period. And since they are long day plants, so they are also called short night plants. Just like the carnation, here the picture of a carnation plant and also petunias. There are many colors of petunias. And the third classification is the day neutral plants whose flowering is not affected by light. So regardless of the length of light period, the plants will flower just like that of sunflower and the tomato. So these are very common plants. Actually, flowering of plants is mediated by phytochrome. And phytochrome is defined as a blue-green pigment found in many plants which regulates various developmental processes. And one such developmental process being regulated by phytochrome is flowering. So we'll take up this part here first. Okay. Here we have this lighting treatment, and under the lighting treatment we have this light, the yellow color, and the darkness, this dark color part. This is in a 24-hour cycle, and we have the flowering response for SDP or short day plants and LDP or the long day plants. So as we learn, if the short day plants are exposed to short day condition of light, so and long darkness, and so they will flower. But LDP will remain vegetative or they will not flower. On the other hand, exposure to long photoperiod and short darkness or dark period will make the SDP vegetative and LDP to flower. Okay. And exposure to short photoperiod and interaction of light during the dark period will render the SDP vegetative while LDP flower. Okay. Interruption of the daylight period by darkness. This is a long day period, if it is being interrupted by darkness, this will result to the vegetative phase of SDP and promotes flowering in LDP. Here it is somewhat similar in the length of the light and dark period, so this will make the plant SDP vegetative and flowering for LDP. This condition, as you can see, there is shorter photo period and longer darkness or dark period. So this is favorable to the flowering of the SDP and vegetative condition for LDP. Here we have another illustration, just like that of the sharing interruptions also, aside from the long day and short day condition. So below here is along the plants. Okay, we can see here flowers, no flowers, flowers, and so on. And on the other side, on the upper side, we also have these plants with. This is actually a short day plants, and there is no flower. There is flower. There is no flower, and then flower, no flower, and there is flower. So we have here the critical day lamp, the dashed line at the center, as we have defined previously or described previously, short-lived plants will will not flower if they're exposed to long photoperiod. So that's why there's no flowering here. But if the long-lived plants are exposed to long photoperiod above the critical big length, of course they will flower. Okay. In the second condition, there is short photoperiod and long period of darkness. So this is conducive to the flowering of short-lived plants and vegetative condition for lonely plants. Okay, the interruption of darkness by wind light, this flash of light renders the lonely plants to flower, while lonely plants to flower, even if the the continuous exposure to light period is short. You can see it's below the critical day length, but then the light interruption during darkness makes it flower. So there are more phytochrome that is being synthesized in this condition, which is inhibitory to the flowering of the short-lived plants. In the fourth uh, column, again we still have this short-lived condition. Uh, Supposedly, this is inductive to the flowering of uh, short-lived condition. So this is inductive to the flowering of the of what's this of the shortly plants, yes. And the interruption of grid light followed by far red light uh, is conducive to the flowering of shortly plants. Unlike in the third condition, where the red light inhibits flowering of the shortly plants. But this FR or far red light exposure is inhibitory to the flowering of lonely plants. In the third condition or in the third column, we have the interruptions red light, far red light, and red light, which causes flowering of the lonely plants and non-flowering of the shortly plants. So just like in the third R, the red light, because this red light favors the production of phytochrome. And in the last condition, so again, we still have this shorty condition below the critical diagram, and then the the dark period is being interrupted by uh, an alternate exposure to red light, far red light, far red light. So if it is far red light, which is the last exposure, this is inhibitory to the flowering of lonely plants, but inductive to the flowering of the short-lived plants. So you can see here flower, here no flower. So please uh, go over this. It's hard. I know it's hard to understand this mechanism. So you should try to examine the given situation when there is a lonely condition, when there is shorty condition. So there's a difference in the response of the long day and short day plants. So we have here the summary differences between SDP and long DP and long D plants. So for here in the shorty plants, long D plants, so flowers when the photo period is less than the critical day length, whereas LDP flowers when the photo period is more than or greater than the critical day length. So as I mentioned a while ago, this critical day length serves as a boundary for the inductive and non-inductive ranges of photo period. Okay. Second, interaction during the light period with darkness does not inhibit flowering for short-day plants. However, interaction during the light period with darkness inhibit flowering for lonely plants. Flowering is inhibited if the long dark period is interrupted by a flash of red light for short-day plants. Okay, on the other hand, flowering occurs if the long dark period is interrupted by a flash of light. Okay. Again, this flash of lights causes the synthesis of phytochrome, which is inductive or favorable to the flowering of LEPs. Fourth difference is long, continuous, and uninterrupted dark period is critical for flowering, whereas for LDP, dark period is critical for flowering. Then fifth, flowering does not occur under alternating cycles of short day and long and short light period, while in LDPs, flowering occurs under alternating cycles of short day followed by still shorter dark period. Okay, aside from the three categories of photoperiodic plants, we have additional. We have the so-called intermediate categories of plants, which are first the long, short day plants. So these are actually short day plants, but must be exposed to long days during early periods of growth for subsequent flowering, just like that of Bryophyllum. So there must be the exposure first to long photoperiod before they are exposed to short photoperiod. This is what we mean with long, short day plants. And the other one is short, long day plants. So these are actually long day plants, but they must be exposed to short day condition or photoperiod during early periods of growth for subsequent flowering, just like the varieties of wheat and rye. Hey, another phenomenon controlling flowering of plants is vernalization. Okay. Vernalization actually is the promotion of flowering in response to prolonged exposure to low temperature, uh, usually 2 to 8 weeks at 4 degrees centigrade. And we have here the sample. This is these are petchai. These are petchai plants exposed to low temperature, and you can see here bolting of the petchai plants. Okay, after bolting, there is now the flowering. Actually, this bolting is a characteristic of the plants with rosette growth habit. So they have to bolt first or to elongate their floral stalk must elongate first before it can bear flowers. And it is reported that there is a quantitative relationship between the length of bulk treatment and acceleration of flowering, which means that the longer the length of low temperature exposure, okay, the shorter the flowering time will occur. So this is a case also of acceleration of flowering in plants with exposure to low temperature. And this is enhanced when the length of low temperature exposure is being lengthened. The third, or another way of controlling flowering in plants is the use of plant growth regulators or PGRs. And there are five classical plant growth regulators. And one is gibberellins, and these are the well-known popular effects of gibberellins on stem growth, both in lonely plants, induction of seed germination, enzyme production during germination, particularly um, the production of alpha amylase enzyme, fruit setting and growth, and the induction of maleness is one of the well-known effects of gibberellins. And the picture at the side is or are celosia plants, are the commonly called tapay-tapay, and these are actually this is a research of my high school advisee. So this plant here at the left is being applied with gibberellic acid. Uh, One of the gibberellins, there are more than 100 types of gibberellins, no, from JA1, JA2, JA3. So this is the most active gibberellins, the GA3. Another one, the other plant is being applied with PBZ or paclobutrazole. So you can see that the one applied with gibberellins has or yes, taller plants or longer stalk, whereas that of PBZ is shorter. So that's one of the well-known effect of gibberellins on stimulation of stem growth. And we have also commercial uses of gibberellins. the fruit production increase, uh, stock length of seedless grapes, malting, increased sugar cane yield, and it's also used in plant breeding to reduce the time for seed production. Okay. Sometimes sometimes we there are instances that we don't want polar plants. So we use this gibberellin biosynthesis inhibitor. Okay. There's always the time that tallness is a disadvantage. Often we say that uh, tall, being tall is an advantage, but sometimes it's not. Just like in the case of some varieties of rice which are tall, okay, this tallness is a disadvantage because if there is strong winds, these tall varieties of rice will easily nudge, and this will make the cultural management practices, particularly harvesting, very difficult. So this is there are times that we want to inhibit the growth of the plants, and we are going to use this inhibitor. And the well-known gibberellin inhibitors are ansaimidol, which is known commercially as A-Rest, and the other one is paclobutrazole or PVZ. This is the one we use with uh, with the Celosia a while ago, the picture I have shown you, and the brand name commonly or that are commercially available are the Coltar and Bunzi. So I have been using this Coltar in the in my thesis before and also in the thesis of my advices. Okay, another PGR is dioxin, which is also known for its effect on cell elongation and on apical dominance. Okay, we define apical dominance as the phenomenon where the terminal buds inhibit the growth of the lateral buds, and so the tendency of the plant is to grow tall. So just like this one, with apical meristem intact, the plant actually this is Mayana plant, one of the trending plants we have. Many plantitas and plantitos are having this plant. I have also some collections of this plant. So if we will not cut off the shoot part of the plant, okay, this will continuously grow tall, because the meristem is intact and it is in the meristem or the shoot apex where the auxin is produced. The other picture now shows the apical meristem being cut off, and so the site of auxin biosynthesis is being removed, and this allows the lateral shoots to develop. So the removal of the cytokinin biosynthesis allows the effect of cytokinin to be expressed, which is on the formation of lateral shoots. And these are some of the well-known effects of auxin, such as on cell enlargement, cell division, vascular tissue differentiation, root initiation, tuberosity response, apical dominance, proceeding down to promote promotion of femaleness. And the commercial uses of auxin is on prevention of fruit and leaf drop, promotion of flowering of pineapple, uh, induction of parthenocarpic fruits, thinning of fruits, rooting of cuttings for plant propagation. So it's also well known to promote um, rooting. And in higher concentration, auxin are also used as herbicides, just like that of the Tofordi and the Kamba. So these are herbicides. Okay, the third PGR is the cytokinin with its well-known effect on cell division morphogenesis down to chloroplast development. And another PGR is the ethylene, which has also this well-known effect on releasing from dormancy, shoot and root growth and differentiation, a adventitious root formation, abscission of leaf and fruits, flower induction in some plants, the very well known induction of femaleness. So more female flowers are being produced. This is true in plants having the monoecious flowering habit, where male and female flowers are producing on plant, not just like the cocoa beans. Okay. It also affects enhanced flower opening, also flower and leaf senescence, as well as fruit ripening. So ethylene also induces fruit ripening, and in fact, it is also sometimes known as the uh, fruit ripening hormone. And commercial uses, it it hastens fruit ripening in many fruits, just like in tomato, in apple, in banana, and synchronizes flowering and fruit setting in pineapple, accelerates abscission of flowers and fruits, or falling off, or removal from the plants, promotes female sex expression in cucumber. Actually, it's not only in cucumber, but in general, it's on in cocoa beans. Inhibit terminal growth, promote lateral growth, and compact flowering stems. And we have the next, the fifth, the abscisic acid, also known as ALBA, and with its different effects, just starting from induction or causes stomatal closure, inhibits shoot growth down to the increase in ABA in response to bonding induces gene transcription, notably for proteinase inhibitors, and it will be involved in the defense against insect attack. Okay, the next phenomenon or controlling flowering is protected cultivation, which is a cropping technique wherein the microclimate or a condition very close to the plant, that's what we refer to as microclimate, surrounding the plant body is controlled either partially or fully as per the requirement of the plant species growing during the their growth period of growth, during their period of growth. And we have these samples of plants, ornamental plants in particular, that are grown under protected cropping or protected cultivation. And it's really amazing to see these beautiful flowering plants. So we have this anthurium on top. We have this mixture of plants, maybe bryophyllum or African violets, and below are roses. So it's really amazing to see these plants with their very beautiful flowers. And there are many benefits of protecting structure. Okay, they protect the plants against the impact of heavy rainfall, protection against temperature extremes, protection against biotic stresses due to pests and diseases, and protected cropping or protected structure assures continuous supply of fresh vegetables throughout the year, particularly during rainy months, when such products would be difficult, if not possible to, if not possible to grow. There are several types of protective structures. We have the greenhouses, uh, the plastic houses, screen houses, rain shelters, and tunnels. So we have here the sites, the different protective structure. Here in the issue, we have the rain shelter, something like this, and also we have these tunnels. We made the structure farmer friendly, and so that's why we are using the low cost materials, not just like the bamboo, which are common in the farmer sites for them to easily construct these protective structures. Another another way or technology of controlling flowering is the use of hydroponic system, which is a system of growing plants in nutrient solution with or without the use of artificial medium. And there are two types of hydroponic system: the liquid and the aggregate hydroponic system. And so we can see here plants that are grown hydroponically. So for the liquid hydroponic system, the roots of the plants are bathed directly in the nutrient solution and there is no supporting medium for them. just like the growing of these ornamental plants below. So the the roots are directly soaked or immersed or growing in the nutrient solution. The aggregate hydroponic system, on the other hand, utilizes a particulate material which provides support for the growth of the roots. And the ideal aggregates are those which are inert, meaning they don't contain any nutrients, then porous and they have high water holding capacity, just like the very commonly used aggregate materials, the coco coir and the river sand. So these are set up using aggregate materials for the hydroponic system. So I guess this one here uses the coco coir. Uh, Also for the anthurium. Okay, another technology for flowering of plants, not only for flowering of plants, this is also a technology which controls or solves soil-borne problem. Uh, is this is grafting technique or technology, which is defined as an art of connecting two pieces of living plant tissues together in such a manner that they will unite and subsequently grow and develop as one composite plant. And in grafting, we have two parts. Below the graft union is the rootstock, which is destined to develop into the root system, and above the graft union is the scion, which is destined to develop into the shoot system, the one which will produce flowers and fruits. So this one here, this is the scion being inserted into this rootstock. And I think this is a rose plant, and these one also are grafted lignum, and we also have these grafted cacti. Okay. Other production practices for ornamentals includes one is thinning. So actually the name of the production practices describes what is being done with the plant. So for thinning, this is the removal of the undesirable growth like inward growth, weak stems, blind shoots, and crowded growth. This is to remove those unwanted plant parts, to improve the aeration or ventilation within the plants, and also competition for the different plant parts. Okay, the second is desuckering. This is the operation of removal of suckers from rootstock, just like the shoots produced below the bud union on rootstock. So from the word itself, desuckering. So there is the removal of the suckers. De means remove. Then the third is pinching. Pinching is the removal of a part of terminal grain portion of stem. This is done to reduce the plant height and to promote axillary branching. Pinching of blind shoot is beneficial to increase flowering. Okay, the fourth is disbudding. So this is the removal of undesirable buds and keeping only the central bud and removal of others which cause development of a quality bloom. And this is done in standard roses to reduce number of flowers. The number five is removal of young vegetative shoots. This practice is also known as de-shooting, and this is generally followed in roses. Young vegetative shoots developing from axils of leaves of basal and lateral shoots are removed to allow only one terminal shoots. And this is important from the point of stalk length. And number six is defoliation. So under special condition, it is followed, but it has been reported that removal of leaves from rose plants will increase number of blind shoots, and this defoliation will force the plants to produce growth and flowering during a desired period. Number seven practices is removal of faded flowers. So if the open blooms are not removed in time, there is chance of developing fruit-bearing seeds. And once the hips are formed and reach the advanced stage of development, growth and flowering are severely reduced during the season. And the cutting of these faded flowers will force to produce strong lateral shoots which will produce good quality flowers. So that's all for the ornamental crops aspect. Now let's proceed to the plantation or industrial crop production system. We define plantation or industrial crops as crops having usually perennial in growth habit and generally requires changes in the structure of the product. We call these changes in the structure of the product secondary processing before utilization. And we have these categories or classification of industrial crops. The number one is oil crops. This includes coconut, African oil palm, and others. So we have here at the sides coconut, and is one of the secondary product, which is oil. Okay, another group under industrial crop is the fiber crops, which includes abaca, maguey, sisal, pineapple, and other fiber crops. And we have here samples of the abaca plant with the primary product, which is fiber. And the third classification or groups of plants under industrial crops is the beverage crops. Examples we have cacao, coffee, tea. So they are used as beverages. The next other groups of plants is the latex or resin producing crops, just like the rubber and papaya. So they are characterized to produce these latex here. This white uh, coloration we can see in the trunk of the rubber. You can also this in papaya once they are wounded, no, even in the stem of the plant and also in the leaves. No, they produce this latex. Another groups are the spices used for flavoring, condiment for color or coloring of our food, and essences used for or as perfume, just like the black pepper, the vanilla, and the citronella. Okay, we also have these medicinal crops, just like the passiflora, iris, tubli, the lagundi, the carabo, and many others. So they are uh, sources also of medicine to cure diseases. So for the practices done in plantation crop production, so we have first the crop selection. Although we have taken this up in the early part of our class. So for crop selection, we have to consider factors in selecting the crop to be planted or to produce. So one is, of course, adaptability. Okay, whether the soil and climate requirements on the crop is in the prevailing area is suited to the requirement of the proposed plantation crop. And then the yield potential in relation to the required input. Okay, the market is always this is always very important to consider the demand and the preference of the consumer, and then the government policies. So because if the crop you planted or you are planning to pursue planting is a priority of the government, so you can avail support from the government. And then the labor requirement um, involved in uh, crop production or in producing these plantation crops, and then the effect of growing the crop to the environment, and of course the knowledge on the culture of the crop. So we have to have this technology on how to grow them successfully. And what are the qualities of good planting materials? So this is often a question. In order for our crops to yield higher. So we should start with a good quality planting material. So number one is they should come from reliable sources, from registered or accredited nursery or seed supplier. So you should not just get or ask or buy from anywhere. So it should be from registered or accredited nursery in order for us to have these quality planting materials. And then it must be prototype, meaning they contain or they inherit the characteristic, the good characteristic or quality or traits of the mother plant. So exactly the same from that of the mother plant. And then the seeds. The seeds should be pure, no mixture, and viable, meaning they have high percent germination rate. Percent germination and germination rate. And then the transplant should have excellent vigor so that we can easily adapt to the new environment when they are transplanted to the field. And we should consider the cost, affordable cost. Okay, the plantation site selection, so we should consider the suitability of the area. The area must be evaluated in terms of this aspect, okay, ecological, economic, biological, and sociological. So ecological pertaining to the environment, and then economics to the commercial or to the financial aspect of this production, whether there is profit out of this production venture, and then biological factors, the living organisms, say for instance are there pests in that area, so this should be considered uh, uh, for the production to be successful, such that we should be familiar with the prevailing condition in the area. And then sociological factor, so the people near the site where you want to establish your plantation crop production. Okay, in terms of the suitability of the area, evaluation must include uh, evaluation or monitoring of looking into the terrain of the area, whether flat, whether rolling or sloping, because for sure this will affect the cultural management practices that will be done to the plantation crops. And then, of course, the soil characteristics, which refers to the physical and chemical characteristics of the soil, because surely this will affect the health of the crops later uh, via the availability of the nutrients. And then the type of climate of the area, whether it's favorable to the growth of the crops, and then the existing facilities, which refers to the road networks, uh, whether it is accessible in going to the area and also to the market, and then irrigation, source of water, and then electricity. Uh, if we want to have this, if we want to use this electricity for applying the irrigation water or if we are doing overtime works. And then storage facilities, in case we'll harvest and it cannot be sold immediately. And then the ports as well as the communication means and the other facilities must be looked into if they are available. And then accessibility, whether we can go immediately or reach immediately the site with the use of a vehicle. It's very hard if it cannot be accessed with vehicle. It's hard to be walking for a long distance. I have done this before where when we survey the sites for our vegetable project area, we were told that area, the vegetable area is just at a distance, but then we have reached very that far, and I was already very tired. So with that situation, so it's not accessible, so we didn't consider that area. And then, of course, the market of the produce is very important of the market. And also to be considered is the peace and order situation and socioeconomic condition of the people in the area. So, what by mga bad people around the area which will uh, endanger our lives, something like that. And also, if the people are good, no, dili ba sila mangawat, no? Mutabang ba sila bantay sa atong area? So, something like that. And then, before establishing our plants in the field, okay, we should have the nursery, because it is in the nursery where we are going to plant or put our planting materials before they are field planted. So it's important. This nursery is very important if establishing large scale plantation is being will be ventured, because this nursery will give us the quality. Quality is being, in terms of planting material, is being guaranteed. Then there is really supply planting materials for replanting if you have this nursery, and if they have this nursery with many plants, so this is generally cheaper. Okay, important things to consider in establishing a nursery: we should have this reliable supply of good quality water. So we know the uses of water. And then near a good supply of soil and potting medium, and is located near the proposed plantation site. Of course, it is a must that our nursery should be located near or in the proposed plantation site, so that we will not have any difficulty in transferring or transporting or bringing our planting material to the field from the nursery. And also, if in the case of there is replanting, so it's easy to get the planting materials from the nursery. So recommended nursery practices for raising planting materials of the crops should be followed as much as possible, which includes the seed or the mother plant selection, seed handling or processing, and then the germination techniques, bagging, sexual propagation, a hardening of the planting materials so that they will become ready for field planting, and then quality evaluation and selection. So those of poor quality must be culled or excluded from the planting materials, because it is expected that we will not do good. So for land preparation and field layouting, so the target here is to produce a good soil health, eliminate weeds, and improve soil fertility. So this is the reason why we should have this thorough land preparation. So we make the field ready for planting. We have to make the soil in good health, and we have to remove the weeds and improve the soil fertility. And we have these considerations such as the timing of land preparation, the method, refers to the quality or degree of land preparation, and of course the costs. And the question is, when is the best time to start land preparation? Actually, the answer is it varies, no? Depending on the existing field condition, the crops to be planted, the method or the type of cultivation to be used, no? Whether it's using the hand tractor or just the cargo drone implements. So this that has to be considered too. And then another is that there should be enough time to allow decomposition of organic matter to be incorporated to the soil. That's why usually it's alternate 1 week, alternate plowing and harrowing. So this will allow the decomposition of organic matter and incorporation into the soil to become a source of nutrients for the crops to be planted there. And what are the procedures or steps used in preparing land for planting? Okay, the first one is land clearing. Okay, this is actually elimination of existing vegetation. This is done usually by underbrushing, kanang pagharas. Then the next is field layouting. So we consider here the planting systems to be used and suited for the crops, the root network, irrigation and drainage system, and of course the soil preparation, considering the tillage. How land clearing is accomplished. So, as I mentioned a while ago, it is done by brushing or underbrushing. This is done for small vegetation, just like the weeds and shrub. Okay, there's also the cutting, the piling, the burning for secondary growth forests. And then sometimes it will involve plowing, then application of herbicides, and then harrowing. This is for grassland, particularly for comunal areas. And uh, another is brushing plus plowing plus flooding. What are the important components of a field layout? So the first one is planting system, which is actually the arrangement of plants, uh, whether in square planting system, triangular, or hexagonal, or rectangular, or diagonal, and pincans planting system. So these are the different planting systems from where we can choose from. And then the planting distance is refers to the spacing considering the size of the crop. So if the crop has wider canopy, just like trees, uh, um, they must be spaced farther apart, maybe 8 to 10 meters apart. The soil fertility level. So if the soil is not so fertile, it has been continuously planted, so planting distance must be recommended, and based also on the farming systems to be used and the farm implements to be used in preparing the the area or in coupled with the field layouting. Okay, another components of a field layout is the road orientation, whether east to west or north to south. And why is it necessary to do field layouting? So these are the reasons. Okay, one is to have an estimate of the planting material requirement and to easily locate crop varieties and replacement and help in planning for the establishment of road networks, irrigation system, and other farm facilities. Okay, other production practices for specific for plantation crops, one is pruning. So in our topic on pruning, we define pruning as purposive removal of any plant parts. So that's how we define pruning. So for pruning, so there is what's called as formative pruning, just like that of benching, capping, and then maintenance pruning, such as we want to manage the size of our crop, and then rejuvenation, meaning to reinvigorate the growth and productivity, or making the old plants uh, become young again. Okay, another practice is the cropping system. Okay, we'll have a specific topic on this or elaboration on this. So we have the monocropping, intercropping, diversified farming, and low external input farming. And another practice is providing shelter, just like the protected cultivation, greenhouses, and rain shelter, and modifying light, just like the provision of shading using the trees, nets, or lot houses, extending light using artificial lighting, and then improving sunlight availability through pruning and use of reflectors. Then we also provide physical support, just like windbreaks and propping. So we have discussed these windbreaks before. So these windbreaks will divert the direction or change the direction of the wind, and this propping will support, especially those plants that are uh, heavy, carrying heavy loads or many fruits. So they have to be propped. This means tokhan, no, aron dili so that the branches will not break. And then another practice is growing plants in greenhouses that are through container gardening, soilless culture, just like hydroponics, aquaponics, and aeroponics. Okay, The use of PGRs, we have mentioned this, just like ethylene, which is specific for induction of flowering, fruiting in pineapple, oxin also for pineapple, paclobutrazole for apple, mango, and durian, and potassium nitrate for mango. So these are mango applied or sprayed with potassium nitrate, which are having main flowers. We also have this off-season flower induction. So off-season, so this is outside the normal period of flowering. So for off-season production, for production in mango, this is the use of 1% potassium nitrate. Okay, for pineapple, we have the use of ethyl, 25 ppm, and also calcium carbide or calboro, and we have a specific rate of application of 3 tablespoons of the solution poured to the growing point of the plant, which is usually applied in late afternoon to avoid the rapid rate of transpiration. And another practice is improve food setting, um, particularly on the use of oxine for grapes and apples, and gibberellins for also in grapes and mango. So this is with this picture here is without GA, and this is with application of GA for grapes. So we can see that there are bigger fruits in uh, those applied with GA or gibberellins. And another practice is sex modification. So this is the use of the ethifone or ethylene, which promotes femaleness. This is in cucurbits, and also gibberellins, which promotes maleness. So we can alter, we can modify the sexes of the flowers produced by the cucurbits. If you want to have more female flowers, then we'll apply ethylene. And then if you want to have more male flowers, okay, we apply gibberellin. But oftentimes, we want to have more number of female flowers because it's the female flowers that are that are developed into fruits. And so if there are more female flowers, so it will follow that there are more fruits, and so the higher is the yield. This promotion of maleness is being applied now in breeding purposes, a source of the pollen grains. And we also have this practice of assisted pollination, particularly for African oil palm. African oil palm is also a source of oil, not just like that of coconut. So the palm, if you have not seen African oil palm, so it's found there is a plant there in front or near the security guard house, which is near the obelisk, and we also have here in the department near the tissue culture laboratory. So the African oil palm is monoecious, producing separate male and female inflorescence in the leaf axils in cycle of a variable duration, and very rare is there a male and female at anthesis at the same time. So therefore, there is a need for assisted pollination in most cases to improve yield. Okay, for maximum pollination, there should be at least 50 male flowers at anthesis per hectare of African oil palm. And that's all about the production practices of both the ornamentals and plantation crops. So the next topic will be vegetables and cropping system, and this will be another video. So thank you very much for viewing our topic.